Today we're going to talk about linear functions. So let's remind ourselves what a function is. A function is a rule in which every x has only one y value. We can also say that it's for every input, there can be only one output. Or that for every domain, there is only one range. So today we're going to be talking about linear functions, a certain type of function. And if we look at the term linear functions, we see in the word linear is the word line. So we're talking about linear functions. And a linear function is one that makes a straight line when graphed. Not everything makes a straight line. If it does not make a straight line, it's called a non-linear function. The reason for the straight line in a linear function is that it has a constant rate of change. And so in a nonlinear function, there's obviously not a constant rate of change. So things could go up and down or be curved. Okay? But today we're looking at, is it a linear function? So this is a linear function because we can see it makes a straight line and it will pass the vertical line test. This is a nonlinear function because it is not a straight line. So let's take a look at these examples and see if we can find linear functions. So linear functions have to be a straight line. So we can see that this is a linear function. It passes the vertical line test and it's a straight line. This, the second one, is a non-linear function. Although it passes the vertical line test, it's curved. Now, for this third graph, we see that this is not a function. It will not pass the vertical line test, so we can just cross this one right off. The fourth one, this horizontal line, is linear and it's also a function, so we could call this a linear function. Let's look at this example now of a linear function in a table. So we see this mouse, and on day 1 he has 2 pieces of cheese, and on day 2 he has 1, 2, 3, 4 pieces of cheese. Day 3 he has 1, 2, 3, 4, 5, 6 pieces of cheese, and on day 4 1, 2, 3, 4, 5, 6, 7, 8 pieces of cheese. So when we look at the inputs compared to the outputs, we see that every day is increasing by 1, and that every piece of cheese is increasing by 2. So we can see that we're looking at a rate of 2 over 1 because we're always looking for the change in y over the change in x. So we can see that it's increasing at a rate of 2 pieces of cheese per day. This will allow us to predict the 5th column because there's this pattern. Even though we don't see the 5th day, we can predict that there will be 10 pieces of cheese if the pattern continues with this constant rate of change. Let's take a look at another example. In this example, on day 1, we see the mouse has 2 pieces of cheese. Day 2, there's 4. Day 3, there's 3. And day 4, there's 6. Well, even though the days are still increasing by 1, the pieces of cheese are not increasing at a constant rate. From day 1 to 2, we have an increase of 2. Then we minus 1. And then from the 3rd day to the 4th day, we add 3. Since there's not a constant rate of change, looking at the change in y over the change in x, right? We have 2 over 1, then we have negative 1 over 1, and then we have 3 over 1. We can see that these are not equal. There is not a constant rate of change, and if we graphed these points, our line would not be straight. So if we look at this example, we're always looking for the change in y over the change in x, which is our slope, right? Slope is change in y over change in x. So as we increase our y values from this one to this one, it's increasing by 10. But over here, we're increasing by 1. Well, from 20 to 40, it increases by 20, but from day 1 to 2, or from value 1 to 2, it's increasing by 1. So when we're looking at change in y over change in x, the first set of values, it has a rate of 10 over 1, or 10. But the second rate of change is 20 over 1, which equals 20. So this does not have a constant rate of change, and this would be non-linear. We still see that it's a function. Each x has only one y value, so it's a function, but it is a non-linear function because there's not a constant rate of change. And again, if we graphed it, it would not make a straight line. Let's look at another example. In this table, we see that our change in y is plus 10 for this change of 1. So we're looking at 10 over 1. Here we see that we're looking at an increase of 10 over 1 again. Okay, so this simplifies to 10, this simplifies to 10. The next one is a rate of 20 over 2. Initially, you might think that that's not the same, but if we set it up 20 over 2, our change in y over change in x, it simplifies to 10. And 50 to 80 is a change of 30, but over here we have a rate of 3 from 4 to 7. So again, we're looking at a rate of 30 over 3, which simplifies to 10. This does have a constant rate of change. It's 10. Therefore, this is a linear function. Again, we'll know it's linear because each x has only one y output, but we also know that it's going to have a constant rate of change. So here are some examples for you to work, and then we can talk about the answers. The first two tables have the ordered pairs put in. The second one, you'll need to take the ordered pairs and put in the value of x and the value of y before you work them. So pause here and solve, and then we'll look at the answers. Okay, we can see that the first table has a rate of change of negative 3 over 1 every time. So we know that this is going to be a linear function. You can see that each x has only one y, and there's a constant rate of change. That second column, we can see that we the rate of change changes, right, from negative 3 to negative 1, to 1 to 3, which means we do not have a constant rate of change. So this will be non-linear, although it is linear, right, because each x value has only one y value. We know it's linear, but it is a non-linear function. And let's take a look at the last one. We see that we have a rate of change of negative 6 over 5, negative 2 over 5, negative 2 over 5. Since there is not a constant rate of change, this again is a non-linear function. Still a function, each x has only one y, but it is non-linear. All right. Now, on this first slide, we saw that there were more things that described a linear function and a nonlinear function. So I want you to recognize that in a linear function, an equation can be written as, in standard form, as ax plus by equals c, where we have a coefficient with x, a coefficient with y, and then it's equal to c, and also y equals mx plus b, which is the equation for a linear function. But it cannot be written in these forms. X or y cannot have an exponent that is not 1. An exponent has to have what looks like no exponent or a 1. Any other value will make it nonlinear. X and y cannot be in the denominator. It cannot be the exponent. It cannot be in the radical sign, an absolute value bar, or several other things. And also, the last thing is x and y cannot be multiplied together. Okay? So if we look at these examples of equations, we can see that they are all linear. And when we graph using x and y table, it will result in a straight line. So we have this, which should look familiar in the form y equals mx plus b. Y equals 4, which would end up being a horizontal line and would pass the vertical line test. And y equals 2500ths x minus 3. All examples of linear equations. On this slide, we see that these equations are all nonlinear, and if we graph them, they'd be curved or broken lines. Again, here we see that we have x has a power greater than 2. Here we see that x is in brackets, and here we see x in the absolute value signs, or in the radical sign here in this one. We have x in, and that's not going to work. So if we look at this example here, I'd like you to cross off anything that is a non-linear function, and let's see if we can find the linear functions. Go ahead and pause here. Okay, so the first one we see is written in standard form, so this is definitely a linear function. We have 3x plus 2y equals 10, and we could actually put this in y equals mx plus b form. For the second one, we have x being multiplied by y, and that cannot happen. X would actually end up in the denominator, and x cannot be in the denominator. Here we have x squared, and anytime we have x with a value that's greater than 1, with the exponent greater than 1, this will not be linear. Y equals 12, we already talked about, that is a function, a linear function. It would make a horizontal line. In this last one on the top row, we see x as the exponent, and that is not allowed to happen when you're looking at a linear function. Here for this one, we see that x is inside the absolute value sign, and that is not going to give us a straight line. Here we have x as a denominator, and again, that will not work when we're trying to make a straight line. Y equals x plus 3, perfect for a line. X equals 8 is going to end up to be a vertical line. We need to have a y when we're looking for a linear function, so this is not going to work. And here we have 6x equals 9 minus 4y, which is going to give us a straight line.